So in this portion of the video, I want to talk about the formulas for surface area and volume, and I want to concentrate on both types. So we have these polyhedrons. In this case, these are all prisms because they all have two polygonal bases. They're polyhedrons because they're made up of all flat sides and polygons, no curved edges. Whereas over here we have cylinders, not polyhedrons, but they still kind of fit under the same formulas because don't cylinders have two equal parallel bases? So the formula we're going to use for surface area for all of these figures is surface area equals lateral area plus two base areas. So what I wanted to do is just start with this figure here, which is a right regular hexagonal prism. Okay, so what I've done is I've wrapped just printer paper around this prism, but I've wrapped it around the lateral faces. Okay, remember, lateral faces connect the bases. So the lateral faces are all rectangles, and how many rectangles would there be? Well, for a hexagonal prism, there would be 6 of them. So what I wanted to do is just show you something real quick. Obviously, there would be a top and a bottom, but I want to focus on the lateral faces, right? So basically what I've done is I just want to unwrap this, okay, and just unfold this, okay? So what I want you to see here is, if I can just do this the right way, there we go, is after unfolding this, I'm going to have 1, 2, 3, 4, 5, 6 rectangles, but I want you to notice that when you unfold or unwrap the lateral area, it forms a rectangle. Now notice, where did the top of this rectangle come from? Well, if I put this back together, I want you to notice that this green line that I have highlighted up top is going to wrap perfectly around the perimeter. Look, as I roll this, it's going to wrap perfectly around the perimeter of the prism. So when we start to use the letter P in the formula, P stands for the perimeter of the base. One more time, as I unwrap this, the perimeter of the base was once, the perimeter of the base is now the length of the top of this rectangle. Okay, that's going to come into play in a few minutes. Now, the reason why we're going to include cylinders in this same section is it has a lot of the same properties and formulas. So for a cylinder, if I want to find the total area of the outside surface, or surface area, it'll be lateral area, which I have wrapped in white printer paper, lateral area plus 2 bases, okay? So now as I unwrap this, I want you to notice again, when we unwrap this, we're going to find that lateral area, right? But this paper, think about it, these 2 lines that I have in green are going to, as I roll this up, are going to wrap perfectly around the bases, okay? So when we start to use the letter P in this example, all right, stands for the perimeter of the base. The perimeter of the base is also going to be the top length of the rectangle. Okay, so let's try to put what we just talked about into practice. So first and foremost, guys, I want you to make sure that you see the attachment on Google Classroom. I printed this. If you can print it, great. If not, just pull it up on your screen, all right? But basically, this is an organizer for the only formulas we're going to need for this entire chapter. Now, we're only going to focus for the next couple days on just prisms and cylinders. We'll get to the other ones later on. I want you to notice that if they want just the lateral area, which was like the unrolled rectangle, which we'll talk about in a second, then I would just take P times H. Now, P stands for perimeter of the base. So I'm just going to abbreviate there. I'm going to write perimeter of the base. That's P. What do you think H stands for? H is simply the height of the prism. Okay, we're going to practice that in a second. All right, now for total surface area. Now we want to include not only the lateral area, but we also want to include the 2 base areas. So surface area is found by taking lateral area, right, which was perimeter of the base times the height, plus 2 capital B's. Now that's something we're going to have to get used to. Capital B means area of the base. Volume for any prism is just the area of the base multiplied by how tall it is. All right, so what I want to do is I want to start with prisms here. I'll come back for cylinders in a minute. Okay, but remember, surface area is going to be the lateral area plus 2 base areas volume, area of the base, multiplied by how tall it is. So in your work for today, I actually want to go over questions 6 and 7. So here's like some free answers, guys, all right? So but basically what I did was I drew the net myself, right? I took out a ruler and I basically unfolded this and flattened it out. So I took a 3-dimensional solid and flattened it out into a 2-dimensional set of polygons, okay? So if you notice, I took the base and I highlighted them in yellow. The bases are both right triangles, okay? So I have 2 bases here, right triangles. I took the 8 and the 10 and just labeled them here. Now I just want to focus on one capital B. All right, so if I want to find the area of one base, and I have my calculations down here, right? It is a triangle. It's a right triangle. So now maybe it might be a little more helpful to look at it this way, right? So I'm going to take that 8 and copy it down here, right? Because each base is congruent. Each base is the same exact size. Now, if you look at this right triangle here, I have the 2 legs, which is basically the base and height that I need to find the area of the triangle. So what I'm going to do over here is, in order to find one capital B, one base area, I'm going to use the area formula for a triangle. So I'm going to do 1/2 times 8 times 10. 8 times 10 is 80, cut in half. Ladies and gentlemen, one of these yellow spaces is 40, do we have units here? No, it's 40 units squared. Okay, now I'm going to need that information. As you can see, I have 2 capital B's in my surface area formula. I have 1 capital B in my volume. I'm going to need that in a few minutes. That's important. Okay, so now as you've noticed in my red boxes here, ladies and gentlemen, you will be required, when you are going to show your work, you're going to be required to write the formula every single time. Then you're going to show your substitution. Then you're going to finish with your answer. Okay, so now surface area. Okay, surface area. I want you to understand, you could basically find just the areas of all of the surfaces and then just add them up. Okay, but as of right now, look, 2 capital B's, 2 base areas. So this one is 40 units squared, this one is 40 units squared. So what I'm going to do is substitute my area of the base is 40, which means together the 2 bases would have 80 square units of area. Okay, now I want to focus on the other part here, right? Perimeter of the base times the height. Well, the height of the prism is pretty simple, right? The height of the prism is right here. The prism is 10 units thick. It's not this 10, but it's how tall the figure is. It's basically the distance between the bases, right? So it's 10 units tall, so I'm just going to take that 10 units and replace it for height. Now here's the tricky part, okay? The P is the perimeter of the base. So now I know that the base is going to be 8 plus 10, oh wait a minute, plus whatever this is. Okay. Now, just to save some time in the video, I ended up going and calculating that beforehand. So notice that if this is a right triangle, I can use 8 squared plus 10 squared equals c squared. I've done that on the side here. You can pause the video if you'd like to see how I did that. I went step by step and simplified my radical. So what I'm going to do right now is I'm going to label that on the net. So that is going to be 2 radical 41. Okay. If I were to fold this back together, this 8 would land on this side here. So I'm going to put an 8 there, and then this 10 would kind of flap on to this side right here. Okay, so my lateral surfaces, let's think about this. Since the prism is 10 units tall, I could basically put 10s all the way through here. All of my lateral edges are 10 units tall. So here, let me try it one way, right? 8 times 10, so this rectangle is 80 square units, okay? This is actually a lateral face, but it's 10 by 10. So its area is 100. This rectangle in the middle here is going to have a radical expression, right? It's 2 radical 41 wide by 10 tall. So what is 10 times 2 radical 41? It's 20 radical 41. Okay, so technically, guys, my lateral area is 80 plus 100 plus 20 radical 41. Okay, I'm going to just say you could literally just add up all these faces and get the total surface area, but I do want to practice using the formula. So what I want to ask you is, what is the perimeter of my base? Well, it's going to be 8 plus 10, which is 18, plus 2 radical 41. So I'm going to write that in here. 18 plus 2 radical 41. You got to write small. Now I have to multiply that by 10. So I'm going to distribute. So far, my surface area will be 18 times 10, which is 180, and 10 times 2 radical 41, which is 20 radical 41. If you notice, 180 right here comes from these two together, plus 20 radical 41, plus 2 bases. So basically, this formula just helps you get to your final answer. Now, I'm going to leave my answer exact. I'm not going to type it in the calculator. 180 plus 80, those are like terms. So my final surface area in exact form will be 260 plus 20 radical 41 units squared. That is the area of all 5 faces together. Okay? And units squared for any area. Now, after we did all that, like we did a lot of the grunt work, so most of the work is finished. Now what we're going to do is come over here. The volume of any prism, ladies and gentlemen, is the area of the base, 1 capital B, multiplied by how tall it is. So this is much easier than the calculations over here. The area of one base was 40 square units, and the prism is 10 units tall. So our volume here is 400 units cubed, right? Because volume is 3-dimensional space. Okay, so that was a tougher one. That's why I wanted to do this one with you together. Now, I'm going to come to my next example, which is question number 7. Now I come to my formula sheet, all right? Number 7 is a cylinder, right? The bases are circles. So things are round now. So now we know we're going to include pi. But guys, remember, the lateral area is still going to be the perimeter of the base times the height. The surface area, the area of all of the surfaces together is going to be the lateral area plus the 2 bases. However, the bases are circles, right? So we're going to use pi r squared twice. Okay, lateral area will be 2 pi rh. We'll get to that in a minute. Volume for prisms and cylinders is always the area of the base times how tall it is. But since the area of the base will be a circle, it'll be pi r squared times how tall it is. Okay, now to save some time, I've come here, I've written down all of my information. Looking at my cylinder, the height of the cylinder is 9. Okay, the cylinder is 9 tall, the distance between the 2 bases. The radius is 7. Now I'm going to use circumference because, guys, remember, we're going to need the perimeter of the base. Okay, but the perimeter is round. So circumference is pi diameter, right? Radius is 7, circumference is 14 pi. I'm also going to need 1 capital B. I'm going to need the area of one base. But one base is a circle, so I'm going to use pi radius squared, 7 squared, 49 pi. All right, I'm ready to go here. Believe it or not, ladies and gentlemen, cylinders I think are a little easier. So what I did was I wrote my formula. Surface area is 2 pi RH plus 2 pi r squared. If you notice, the only things we need will be the radius and the height. We have that already. So what I'm going to do is I'm going to just simply substitute all my information. Okay, I like to use parentheses. I think you should do the same. The radius is 7. The height is 9. So that's going to be 7 here, 9 here. And then let's see, the radius squared, right? So that's going to be 7 squared. All right, so let's think about this. 1 capital B is 49 pi, right? And that's going to be that, okay? So think about it. 49 pi twice will be 98 pi, okay? Surface area. Now, we're going to have 2 times pi times 7 times 9. Well, let's think about this. 7 times 9 is 63. Doubled is 126, and we put the pi after it, okay? So now, this is my lateral area. This is the space in the rectangle, and this is 2 circles, right? One being 49, both being 98. Our total surface area is going to be something pi units squared. So 126 plus 98, well, think about it. Adding 98 is like adding 2 less than 100. So that'll be 226 if I add 100 and take away 2 more. So I'm at 224 pi units squared. Okay, remember, lateral area and 2 capital B's. Finally, my volume is going to be the area of one base. The area of one base, pi radius squared. So we've already done this, but I'm just going to go through the motions. The height is 9, okay? So volume equals, the area of the base was 49 pi. So now we have to take 49 times 9. All right, well, let's see. 49 times 9. Well, 9 times 40 is 360, right? 9 times 9 is 81, right? So what's 360 plus 81? We're going to get 441 pi units cubed. All right, so ladies and gentlemen, please continue to try these examples. Come see me at the Google Meets each day, and please remember to ask any questions you have. Thank you.